Jai Shri Krishna friends. In last lecture we can complete the geometrical isomerism, in which we can discuss about the different compounds which can show the geometrical isomerism, and in last we can think about the number of geometrical isomers possible for the compound, or calculate the number of isomers possible for the compound. Now we can start the second isomerism, which is optical isomerism. Now if we can give the definition or explanation of optical isomerism, or we can say that which type of compound is become an optical isomer, then we can say that isomers which have same molecular formula, same structural formula, same physical and chemical properties. If we can have any isomer which can have same molecular formula, same structural formula also, means the connectivity of atom is same, and if physical and chemical properties are also same, here we can think about that. This is an exceptional case. In optical active compound, in optically active chemical compounds, some chemical properties are different. Meaning is that optically active chemical compounds means some optically active compounds does not show the same chemical property. In the case of reaction of optically active compound with optically active compound, then the chemical properties is different of two isomers. Clear? If we can have the compound which is optically inactive, what is the meaning of optically active and inactive we can discuss in the lectures. But if we can have the compound which is optically inactive, and here we can have a optically active, we can give the reaction, and if we can have an isomer of this optically active compound, we can give the reaction with this optically inactive compound, then the chemical properties are same. Clear? Suppose we can have a two isomer A and B which is optically active, and we can have another compound C which is optically inactive, then the reaction of this and reaction of this is same, or chemical properties is also same. If A gives the reaction with C and B gives the reaction with C, then the chemical properties are same. But if here C is optically active, now if C is optically active, then the chemical properties of A, C and B, C is different. Concept clear? Means if we can have a two optically active compound in a reaction, therefore we can say that chemical properties is different. Clear? Isomer which have same molecular formula, same structural formula, same physical or chemical properties. In some case it is not same. The case is reaction of optically active compound with reaction of optically active compound. Chemical properties are different, but they differ in their behavior towards the light. But they differ in behavior towards the light, and the light is PPL, plane polarized light. Full form of PPL, plane polarized light. If any isomer have same molecular formula, same structural formula, same chemical and physical properties, in some case we cannot say that, but they differ in behavior towards the light, therefore you can say that it is optical isomer, because it's differ from the behavior towards the light, and particular this light which we can use for the behavior is PPL, plane polarized light. Clear? What is optical isomer? Isomers which have same molecular formula, same structural formula, same physical and chemical properties, but it have different behavior towards the light. Particularly it is PPL, plane polarized light. Then the isomer is called optical isomer, then the isomer is called optical isomer, and phenomena is known as optical isomerism. And the phenomena is known as optical isomerism. If we can study about the optical isomerism, we can study about the light, because it depends on light. If we can study about the optical isomerism, we can study about the light. Clear? First of all, what is light and what is the nature of light? We can write some sentence about light. First sentence is that light is nothing but EMW. EMW means electromagnetic wave. Light is nothing but electromagnetic wave. Either it comes from sun or our ordinary light, tube light, lamp, but it is a EMW. આપણે જે પણ કાંઈ લાઇટનો ઉપયોગ કરીએ અત્યારે, ટ્યુબલાઇટમાંથી આવતી લાઇટ હોય, લેમ્પમાંથી આવતી લાઇટ હોય કે સૂર્ય સનમાંથી આવતી લાઇટ હોય, બધી જ લાઇટ ઇલેક્ટ્રોમેગ્નેટિક વેવ છે. એ બધી જ લાઇટ ઇલેક્ટ્રોમેગ્નેટિક વેવ છે. ક્લિયર? નેક્સ્ટ point about the light is 4. Propagation, no need of medium. If we cannot have a medium, light is propagate. We knows that. If light comes from sun to the earth, there is no medium between these two, because from some height there is a vacuum. Clear? So first point is light is electromagnetic wave. Second point is for propagation no need of medium. And third point is vibrations or oscillations are electric field, are in electric field and magnetic field. In the oscillation or vibrations of light, there are two waves. First one is electric field, second one is there are two fields. First one is electric field and second one is magnetic field. Suppose if you can think about the ordinary light, it is PPL, plain polarized light. Now we can think about ordinary light. Ordinary light means the light comes from the sun and lights and tube lights whatever. અત્યારે આપણે જે ઓર્ડિનરી લાઇટનો સોર્સ તરીકે ઉપયોગ કરીએ એ કોઈ પણ લાઇટને લઈએ તો એને ઓર્ડિનરી લાઇટ કહેવાય. શું કહેવાય? ઓર્ડિનરી લાઇટ્સ. ક્લિયર? ઇન ઓર્ડિનરી લાઇટ્સ electric field vibrates in all planes perpendicular to the direction of propagation of light. We can understand this point. In ordinary light, electromagnetic wave or electromagnetic field vibrates in all planes perpendicular to the direction of propagation of light. Means that it is like that. It is ordinary light. It is the symbol of ordinary light. What do you mean by this? If light is propagated through this direction, suppose here a lamp, we can on the lamp, then light is in this space, this all our space. કહેવાનો મતલબ આ કે સપોઝ કે અહીંયા લેમ્પ હોય અને આપણે લેમ્પને ઓન કરીએ તો લેમ્પ ઓન કરતાં એનું જે કાંઈ ટૂંકમાં એમાંથી જે વેવ નીકળે છે, લાઇટ નીકળે, એ લાઇટ ફક્ત આમ નથી જતી, એમ એ લાઇટ આમ પણ પ્રસરી જાય, આમ પણ પ્રસરી જાય, આમ પણ પ્રસરી જાય, બધી દિશાની અંદર એ પ્રોપોગેટ થાય છે, વાઇબ્રેટ થાય છે. મતલબ કે જો આપણે લેમ્પ ચાલુ કરીએ તો આપણને આમ સીધી લીટીમાં જોવા નથી મળતી લાઇટ, કે ભાઈ લેમ્પ ચાલુ કર્યો તો આમ સીધી લીટીમાં લાઇટ આવી, આ બાજુ ને આ બાજુ અંધારું થયું, એવું નથી હોતું મિત્રો. મીન્સ દેટ if you can on the light, then this is the propagation of light, this is the way or direction of propagation of light. And electromagnetic field or electric field is vibrate to the perpendicular to the light in all direction. Suppose light is passing through this direction, then one wave is like that, because it is perpendicular to the way, because it is 90 degree. One wave is like that, it is also perpendicular here. It is the propagation of direction of light. This arrow means that it is the oscillation or vibration of electrical field like that. It means that it is the oscillation or vibration like that. Clear? It is that it is the vibration in this field and it is the vibration in this field. Means that if you can have a direction of propagation of light, it is the direction of propagation of light, its electric field propagates or vibrates in all directions, in all planes. આવી રીતના પણ એ વાઇબ્રેટ થતો હશે, આમ આવી રીતના પણ વાઇબ્રેટ થતો હશે, આવી રીતના પણ વાઇબ્રેટ થતો હશે, આવી રીતના પણ વાઇબ્રેટ થતો હશે ને આગળ વધતો હશે. ક્લિયર? એટલે આપણે બધી બાજુ જોઈ શકીએ. જો ફક્ત લાઇટ આવી જ રીતના પ્રોપોગેટ થતી હોત તો લાઇટ આમ જ જોવા મળત, અહીંયા આપણને લાઇટ જોવા મળત નહીં, પણ એ ઓલ ડાયરેક્શનની અંદર વાઇબ્રેટ થાય છે. ઇટ ઇઝ ધ એક્સપ્લેનેશન ઓફ ઓર્ડિનરી લાઇટ. નાવ ધ મિનિંગ ઓફ ધીસ એરો you can understand. This arrow means this. If the propagation of light, direction of propagation of light is that, therefore this arrow shows that it is the vibration of electrical field like that perpendicular to the direction. it is perpendicular to the direction, it is also. There are so many planes. Here we can donate or write to some planes like 1, 2, 3, 4. There are so many planes. Here also a plane, here also a plane, here also a plane, here also a plane. So many planes are there, and therefore you can see in all directions. Clear? It is ordinary light. Now second word which we can explain in this topic is polarizer or Polaroid. Polarizer, P-O-L-A-R-I-Z-E-R, or Polaroid, P-O-L-A-R-O-I-D, polarizer or Polaroid. What do you mean by that? It is a material which can convert ordinary light into the plane polarized light. It is a material which can convert ordinary light into the plane polarized light, or PPL, and it is a nickel prism. This material or this configuration is known as nickel prism, and nickel prism is made up of calcite. Nickel prism is made up of calcite. Calcite means CaCO3. CaCO3. The material or the configuration or the instrument which can convert ordinary light into the plane polarized light is known as polarizer. And very famous polarizer in the market is nickel prism, which is made up of calcite, CaCO3. Suppose if we can have a ordinary light, it is an ordinary light, and we can pass from the nickel prism, and as a result we can get a light as like that, and this type of light is known as plane polarized light. Clear? Means that now we can have a light in which electric field is vibrate or oscillates in only and only one planes. Now if you can think about that wave, there is a direction of propagation of light, then only one wave, only one plane in which electrical field is vibrate like that. All remaining vibrations are delete. All remaining vibrations are delete. Yes, it is like that also. एक आम पण होई सके, आम पण होई सके, but it can have only and only one direction to the propagation. Remaining all directions are cancel out or delete. Head down, नीचे हजी लखजो के polarizer cut off or delete. Polarizer cut off or delete all remaining vibrations except only one direction. मतलब એ કોઈ પણ એક ડાયરેક્શનના વાઇબ્રેશન સિવાયના બધા વાઇબ્રેશન કે ઓસિલેશનને ડિલીટ કરી નાખશે. કોણ? નિકોલ પ્રિઝમ, which is known as polarizer, which is known as polarizer. Clear? So therefore some words which we can explain here. First is nature of light. What is light? Light is a electromagnetic wave which is no required medium for the propagation. It is a vibration or oscillation of electrical and magnetic field. If we can have ordinary light, it propagates towards the all direction, and if we can have a material like polarizer and we can pass the ordinary light from polarizer like nickel prism, we can get a plane polarized light which can oscillate in only and only one plane perpendicular to the propagation of light. હવે PPL ની અંદર શું હશે તો કે propagation of જે લાઇટ છે, ધારો કે propagation નો વે આ હશે તો એ ફક્ત એક જ પ્લેન ની અંદર ઓસિલેટ થશે, બાકીના બધા પ્લેન જે આવા પ્લેન હતા આમ આમ એ બધા પ્લેન ડિલીટ. ક્લિયર? Now we can think about some other terms like optically active compound or substance. First term is optically active compound or substance. What is the definition? The substance which can rotate the plane of polarized light, which is PPL, either towards the right side means clockwise or left side means anti-clockwise. The compound is known as optically active compound or optically active substance. If we can have any substance which can rotate the plane of polarized light is known as optically active compound. Suppose here if we can have a plane polarized light like that, and if we can pass from the solution of the substance, not a substance, if you can pass from the solution of a substance and it can rotate like right side or it can rotate like left side from the first position, then we can say that this compound is optically active compound. And if we can pass the optically active light from the solution of substance and the optical light does not rotate its plane, it is like that, therefore you can say that this substance is known as optically inactive compound. Clear? What is the optically active substance? The substance which can rotate the plane of polarized light either towards the right side, means clockwise, or either towards the left side, means anti-clockwise. Then the substance is known as optically active compound or substance. And if any compound does not rotate the plane of polarized light, therefore this compound is an optically inactive compound, or this substance is an optically inactive substance. From this, the second one is like that, optically activity. Optically activity. What do you mean by optically activity? It is nothing but property of a compound by which or virtue of which it can rotate the plane of polarized light is called optically activity. Means that if we can have a PPL, plane polarized light, and we can pass the plane polarized light from the solution of compound or substance, and it can rotate like that. અને હવે ધારો કે પીપીએલની પોઝિશન જે પહેલાં આ હતી અને હવે રોટેટ થઈને આપણને આવી મળી, તો એનો મતલબ એવો થયો કે કમ્પાઉન્ડની અંદર, એ સોલ્યુશનની અંદર, કમ્પાઉન્ડની અંદર એવી કંઈક કેરેક્ટરિસ્ટિક છે કે જે કેરેક્ટરિસ્ટિક પ્લેનની ડાયરેક્શનને ચેન્જ કરી નાખે છે. એ જે કાંઈ કેરેક્ટરિસ્ટિક કે જે કાંઈ પ્રોપર્ટી કે જે પીપીએલને ચેન્જ કરે છે, પીપીએલને રોટેટ કરે છે, એને શું કહેવાય? ઓપ્ટિકલી એક્ટિવિટી. ઓપ્ટિકલ એક્ટિવિટી. ક્લિયર? ધ પ્રોપર્ટી ઓફ કમ્પાઉન્ડ બાય વિચ વર્ચ્યુ ઓફ વિચ ઇટ કેન રોટેટ ધ પ્લેન ઓફ પોલરાઇઝ લાઇટ ઇઝ ઓપ્ટિકલી એક્ટિવિટી. એટલે કે પ્લેન ઓપ્ટિકલ પીપીએલના પ્લેનને, પ્લેન પોલરાઇઝ લાઇટના પ્લેનને રોટેટ કરવા માટે સબસ્ટન્સની અંદર જે કાંઈ કેરેક્ટરિસ્ટિક છે, જે કાંઈ પ્રોપર્ટી છે, એને શું કહેવાય? ઓપ્ટિકલ એક્ટિવિટી. નેક્સ્ટ ટર્મ ઇઝ polarimeter. Next term is polarimeter. The question is that how we can measure the rotation, or how we can say that PPL change its plane or not, or PPL rotates its plane or not. It is measured with the help of polarimeter. It is measured with the help of polarimeter. Clear? The rotation of the plane polarized light is measured using a polarizer, or using a polarimeter. The rotation of the plane polarized light is measured using a polarimeter. Clear? So polarimeter is an instrument by which we can check the compound is optically active or not, and what is the rotation of plane polarized light, and what is the angle of rotation. Clear? જો રોટેટ કરશે તો એ કેટલા એંગલથી રોટેટ કરશે? ધારો કે આમ હતી અને આટલી રોટેટ કરે તો 30 ડિગ્રી 30 ડિગ્રી જેટલું રોટેશન થયું. કેટલી રોટેટ કરશે કે નહીં એ પ્લેન પોલરાઇઝ લાઇટને કમ્પાઉન્ડ, એ ચેક કરવા માટે જે ઇન્સ્ટ્રુમેન્ટનો ઉપયોગ થાય એને શું કહેવાય? પોલારીમીટર. યસ, પોલારીમીટર ઇઝ ધ ઓનલી વન વે, one and only one way to detect the compound is optically active or not. Yes, clear? We can take the compound, we can make the solution, and we can go in the laboratory, and with the help of polarimeter we can say that it is optically active or not. There is no another way to check the optical activity in any compound. જો આપણે કોઈ પણ કમ્પાઉન્ડની અંદર ઓપ્ટિકલ એક્ટિવિટી છે કે નહીં, મતલબ કે કમ્પાઉન્ડ ઓપ્ટિકલી એક્ટિવ છે કે નહીં, એ ચેક કરવું હોય તો એકને એક જ રસ્તો છે અત્યારે આપણી આગળ, કે ઇન્સ્ટ્રુમેન્ટની મદદથી તમે ચેક કરી શકો. જે ઇન્સ્ટ્રુમેન્ટનું નામ છે પોલારીમીટર. ક્લિયર? From the structure we can also say that the compound is optically active or not, but which is we can discuss in later. Clear? What is the arrangement of polarimeter, or we can say that the instrument used for the check and measurement of optical activity is polarimeter. It can check and measure the optical activity. It is check it is optically active or not, and it is measure the angle of rotation also. The arrangement of polarimeter is like that. First of all, we can have an ordinary light or source of light or light source. Light source means any light. We can have a lamp like sodium lamp. We can have a lamp like sodium lamp. Suppose we can have a sodium lamp, then it can gives the ordinary light. આપણે જે અત્યારે સોડિયમ લેમ્પ જોતા હોય સ્ટ્રીટ લાઇટની અંદર, ધારો કે આપણે એવો સોડિયમ લેમ્પ અહીંયા સોર્સ તરીકે રાખ્યો, we can on it, it gives the ordinary light, means the propagation or oscillation of the electrical field are in all directions. Now we can put the nickel prism, because we can require PPL, plane polarized light. We cannot require ordinary light. We can put here a nickel prism, and ordinary light is passed from the nickel prism. It can have PPL. હવે શું બની જશે? PPL, plane polarized light. Remaining all planes are delete. Means આનું જે પ્લેન હશે એ એક જ પ્લેનમાંથી લાઇટ પાસ થશે, બાકીના બધા જ પ્લેન હશે અહીંયા આવીને શું થઈ જશે મિત્રો? ડિલીટ. ક્લિયર? નાઉ this plane polarized light is passed through the solution of chemical compound, કે જે કમ્પાઉન્ડની આપણે ઓપ્ટિકલ એક્ટિવિટી ચેક કરવી હોય એ કમ્પાઉન્ડનું સોલ્યુશન બનાવવાનું. કમ્પાઉન્ડ પ્યોર ફોર્મમાં નહીં લેવાનું, અને શું બનાવવાનું? સોલ્યુશન. યુ કેન મેક ધ સોલ્યુશન ઓફ ધ કમ્પાઉન્ડ and we can fill the solution in polarimeter tube. It is a polarimeter tube, or it is also known as sample tube. Arrangement is like that. Here a space from which we can fill the solution in the tube, and here a optical glass. Here a glass, because from this glass plane polarized light is enter into the solution, and from this glass plane polarized light out from the solution, and here analyzer, which is also one type of instrument. Here a analyzer, which is also one type of instrument which gives the result. Either the plane of polarized light is rotate or not rotate. If rotate, then what is the angle of rotation? Clear? It is known as polarimeter. This whole configuration is known as polarimeter. Now we can discuss about the result. Concept clear? Ordinary light, nickel prism, we can get PPL. We can pass the PPL from polarimeter tube. Polarimeter tube means it is a glass. It is a plastic. Here a space to fill the solution. Here solution, we can pass the PPL from that, and here is a result we can get from analyzer. Now we can check. There are three possibilities in result. First possibility is that there is no change in plane of polarized light. Means આપણે જે પ્લેન યુઝ કર્યું, આ પ્લેન આપણે પોલરાઇઝ લાઇટનું યુઝ કર્યું, એ જ પ્લેનમાં આપણને ફરીથી લાઇટ મળશે. Means that PPL is unaffected. If PPL is unaffected, means that there is no rotation towards the left or right side. Therefore we can say that compound is optically inactive. Compound does not change the plane of polarized light. Therefore you can say that this type of compound is known as optically inactive compound. Suppose if the first position of PPL is like that, here we can use here. આપણે ધારો કે PPL અત્યારે યુઝ કરી, એનું પ્લેન આ હશે. Now we can pass from the sample tube or compound, and as a result we can get the rotation in right side or rotation in clockwise. Therefore you can say that the compound is optically active because it can rotate the plane of polarized light. જે પહેલા આવું પ્લેન હતું, હવે એ સેમ્પલ ટ્યુબમાંથી પાસ થઈ ગયા પછી પ્લેન આમ રોટેટ થઈ ગયું રાઈટ સાઈડ. Means that it rotates the plane of polarized light. Therefore the compound is optically active. And this type of compound is known as dextro-rotatory compound, or small d or plus. This type of compound is known as dextro, D-E-X-T-R-O-R-O-T-A-T-O-R-Y, dextro-rotatory compound, or small d. Remember, not a capital D. Here we cannot use a capital D. It is a small d or plus. જો કોઈ કમ્પાઉન્ડની આગળ પ્લસ લખ્યું હોય તેનો મતલબ એવો છે કે ઓપ્ટિકલ એક્ટિવ है, પ્લસ કે પ્લેન પોલરાઇઝ લાઇટને રાઇટ સાઇડ રોટેટ કરે है. Clear? And third result which we can discuss here, suppose here plane polarized light is like that, and we can pass from the solution and the plane is rotated like that, means in anti-clockwise direction or left side. Therefore you can say that compound is optically active. There is no matter, it can rotate right side or left side. If the compound rotate the plane of polarized light, then the compound is optically active. But it can rotate towards the right side or clockwise, therefore it is dextrorotatory or small d or plus. And if it can rotate the plane of polarized light towards the left side or anti-clockwise, therefore the compound is known as leorotatory. Levorotatory, leorotatory, or small l or minus. The meaning of plus, small d and dextrorotatory is same. The meaning of leorotatory, small l or minus is also same. You can say leorotatory or small l or minus, it is same. If plane of polarized light is rotated towards the right side, then it is optically active, but it is known as optically active to છે જ પણ કોના તરીકે ઓળખાશે dextrorotatory. If the light is rotated towards the left side, therefore it is also optically active, but now it is known as leorotatory. But if plane of polarized light does not rotate, then the compound is optically inactive. Now we can discuss about the definition or symbols of dextrorotatory compound and leorotatory compound. First we can discuss about the dextrorotatory forms or compound. Forms means a cis form, transform like that, dextro and leo form. Dextro form or compound means substance which can rotate the plane polarized light to the right side or clockwise direction is known as dextrorotatory compounds. Clear? The substance or compound which can rotate the plane polarized light to the right side or clockwise direction is known as dextrorotatory compound. Dexter is a Latin word. Dexter is a Latin word and the meaning of dexter is right. Therefore you can say that it is dextrorotatory, and the symbol is or denoted by small d or plus. Small d or plus. Now we can think about the leorotatory forms or compounds. Leorotatory forms or compounds. Substance which can rotate the plane polarized light to the left side. Substance which can rotate the plane polarized light to the left side or anti-clockwise direction is known as leorotatory forms or compounds. Clear? It is also Latin word leos, means left side, and which is denoted by small l or minus. Small l or minus. Friends, always remember, D and L are not a absolute representation, but it is a relative ones. D and L are not a absolute representation, but it is a relative ones. Clear? And the compound is a D or compound is a L. Small d and small l is measured by one and only one way, which is polarimeter. If anyone can say that we can have a compound like that, you can measure it is a D or L. We cannot say that it is a D form or L form without the help of polarimeter. Polarimeter થી જ આપણને ખબર પડશે કે D form છે કે L form, because we can put the solution of this compound in a polarimeter. We can pass the PPL from this. If plane is rotated towards the right side, therefore it is dextrorotatory, and if plane is rotated toward the left side, therefore it is leorotatory. From this we can make some conclusion as like that. If theta is higher, then optical activity is more. If theta is higher, then the optical activity is more. What is theta? Theta is the angle of rotation of PPL. Suppose first position of PPL is like that. In some compound, PPL rotates through the angle of theta here, and in some case PPL is rotated to the angle like this theta, which is theta dash. Suppose here theta karta theta dash greater than hai, we can say that in this compound and in this compound have more optical activity. Clear? If theta is higher, then optical activity is higher. Clear? But these conditions is considered with the help of identical condition. The concentration of this solution and this solution is same, temperature is same, remaining all condition, light of wavelength is same. Therefore you can say that if theta is higher, optical activity is higher. Remaining all conditions are identical for the both compound. Clear? And what is the standard or all conditions for the checking of the polarimeter, checking of the optical activity through the polarimeter is that. What is the standard condition to prepare the solution for the polarimeter is concentration of solution is generally taken is a 1 gram per ml. Concentration of a compound is taken as a 1 gram per ml, and generally the length tube or tube of length, this tube which is a polarimeter tube, the length of this tube is generally 10 centimeter or 1 decimeter. Clear? It is a standard condition or conditions for the solution to put in a polarimeter. Clear? In this lecture we can have studied some points like that. What is optically active compound, how we can measure the optical activity, if the compound is optically active or not, it is checked by the instrument which is polarimeter. If the compound is optically active, then it is either dextrorotatory or levorotatory. And what is dextrorotatory, what is levorotatory, which we can discuss here. In next lecture we can start with specific rotation and some cases or examples of the optical activity.